I think I'm going to start recording these and then post these on Canvas for everyone, because you guys have similar questions, and if I make a resource for one person, I want other people to have access to those too. So I'll start sharing those short videos of me going over homework problems, and this one is module 7, homework question number 6. Okay, all right, let's see. Test the claim about the difference between two population means mu1 and mu2 at the level of significance alpha. Assume the sample are random and independent and the populations are normally distributed. Okay, now this part, the last part they just mentioned, if populations are normally distributed, if we know that fact, the sample size doesn't have to be as great as 30 or above, right? So I'm just checking. It says the sample size is, the first sample size is 28. The second sample size is 27. 30 and above is what we want, but it's okay because they told us populations are normally distributed, so we can still go on with this procedure, okay? Now, what's the claim given here? They said the claim is mu1 equals mu2. That's the null hypothesis. Why? Because it contains the equal sign. Anytime a claim contains an equal sign, it could be straight up equal sign, greater than or equal to, or less than or equal to. As long as that they have this equal to piece, that makes it a null hypothesis, okay? The alternative hypothesis doesn't have equal sign. So if we know that's going to be the null hypothesis, and I can see that the first part they're asking us to determine is the alternative hypothesis. Alternative hypothesis is the direct opposite of the null hypothesis. So what is the opposite of mu1 and mu2 equal to each other? We should say mu1 and mu2 are not equal to each other. So that's how you can determine the alternative hypothesis. All right, let's continue. It says determine the standardized test statistic. There are 3 methods of doing this. You can use the formula given in the textbook. You can use TI-84 or StatCrunch to just do the whole test using technology. On your final exam, you are allowed to use a handheld calculator. So TI-84 will be the best method of doing this so that you can prepare for your final exam. But I don't have that with me right now, so I'm going to go ahead and just open up StatCrunch, okay? What's taking so long? All right, let me try again. But when you guys read section, now what is this section? Chapter 7, right? No, I can't remember. Let me see. So comparing 2 samples. Section 8.1. If you read that section, there are a whole bunch of formulas given there. So you can use that formula, but I'm going to use technology. The technology tool that I'm using is called StatCrunch here, okay? So let's see. What test are we doing? That depends. If the problem gives us population standard deviation, then we will do z-stat. If they don't give us population standard deviation, we will have to do t-stat. So please know the difference, okay? Because if you go to StatCrunch or TI-84, you can do z-stat or t-stat when you are testing a claim about population means. So this time, guess what? Take a look at this here for me. Population statistics. They gave us that lowercase sigma. That means population standard deviation for population 1. They gave that to us as 3.6 and another. The second population's standard deviation is 1.5. When they give you that lowercase sigma, you go with z-stat. If they don't give you this, but they gave you little lowercase s, those are sample statistics, a sample standard deviation, then you have to do t-stat. So I want you to please know the difference between which stat you are using. You have to go with z-stat because they gave us population standard deviation. Click on 2 sample. All right, let me make this screen a little bit bigger so that you can see everything I'm doing. Stat, z-stat, 2 sample, and they gave us a summary of everything, right? They didn't give us data. Data will be like when you actually have numbers typed up in var 1 and var 2, like these 2 columns. I'm going to click on with summary and take a look. All I got to do is just enter all the numbers given. Mean for the first sample is x bar number 1. That's 16. Standard deviation is 3.6. You see I'm using all the numbers that have subscript 1, okay? What's the sample size? Sample size for sample 1 is 28. So you need to know how to read all these symbols and know like what represents what. Sample 2 has a mean of 14, and that's x bar number 2. And standard deviation for the population number 2 is 1.5. All right, size. Sample size for sample number 2 is 27. And we are testing a claim that, now this is slightly different, right? What they said is that the null is mu1 equals mu2. But imagine subtracting mu2 from both sides. Think about this for me. If they are the same, if two things are the same, what happens when you subtract them? Like same things like 5 and 5. If you subtract 5 minus 5, you get 0, right? So StatCrunch will use this. If you subtract mu1 and mu2, they equal 0. This is the same thing as saying mu1 equals mu2, okay? The alternative claim is mu1 minus mu2, or mu1 does not equal to mu2. If you subtract two values and they give you anything other than 0, that means they are different, right? Like a big number minus small number, or small number minus a big number, they're not going to give you a 0. So, it's already preset, so, I'm not going to change that default setting, so that's all good. But sometimes you have to change those if you are doing a two-sided test, left tail test or right tail test, but this one is a two-sided test, okay? Because the alternative is mu1 does not equal to mu2. All right, and that's all you really have to do. And click on compute, and they're going to give you everything here, okay? And our job, okay, is to interpret these numbers. The standardized test statistic is the z-stat right there. I'm going to go ahead and copy that number. 2.71, I'm just going to have to round to two decimal places. And the p-value is what we really care about. We want that p-value to come out small. And to me, that looks very, very small. I'm going to have to round that up to 0.007. And small p-value is a strong evidence against the null. Now, the chance of seeing such difference, if they were truly the same, is 0.007. It's less than 1%. So, if you have small p-value, you must reject the null hypothesis. You must reject the null, and small p-value is a strong evidence. Okay, whenever the p-value is small, smaller than the alpha level, look, the alpha that we are comparing to is 0.01. 0.007 is smaller than 0.01. So this is a strong evidence. We have enough evidence at the 1% level of significance to reject the claim. Reject the null hypothesis, which was the claim being made here. So that's how you can do this problem. Let me see if there's another part. No, that's it. I'm going to start because I've been hearing that there is a group chat that you guys are expressing your frustration about being so lost. So, if you guys have, because I don't want one person to send me like everything. If you can send me like 1 or 2 problems, per person, maybe I can just try to answer those and post all those videos on Canvas. But just reach out to me. I will do my best to answer all of your questions, but yeah, but I'll really try, okay? So that was the first one that I wanted to record and share with you today.